Today we're going to start reviewing for your first exam of the year. This is part one of two parts. So this is the first part of your review for the exam. I want to start off by going over the directions for how you're going to access the exam, just so that you start getting familiar with the process. When it comes time to take the exam, what you're going to do is step one, log into your student portal. Once you log into your student portal, you would click right here where it says Apps, Services, Sites. You would click right there. That's going to take you to this page where you're going to click on Performance Matters Testing Platform. As you can see, I've circled it in red. That takes you to this page where you would click on Login to Online Testing, which takes you to this page. Now, this is step 4. So as I wrote here on the top, you got to enter your username. Your username, if you look down here, it's underlined in red what the process is. You got to write your student ID at students.dadeschools.net. That doesn't mean write student ID. That means write your student ID number. I realize for some of you that's common sense, but that's a common question that I get every year. Alright, so here you would write your student ID number at students.dadeschools.net. Now the next common question that I get when students are taking the test, they call me over and they say, "Mister, this doesn't work." And it's usually because you fail to put the S at the end of Dade Schools. You usually write dadeschool.net. It's Dade Schools with an S at the end. Same thing right here. Students has an S at the end. If you don't put those S's, the computer's going to say that's the wrong login information and it's not going to let you access the test. Alright, so make sure you look at every little detail of what it's telling you to write and what you are writing. So if it doesn't work, I would look at that first. So you would write your student ID number at students.dadeschools.net in that box, and underneath it you write the password that you use to access your student portal, the same password. If by any chance you get to this page and these boxes don't properly load, then that takes me to what I wrote here. Important. If this web page does not load properly or does not let you log in, you need to switch to a different browser. So either Google Chrome, Firefox, Internet Explorer, or Safari. I usually recommend using one of these two, either Chrome or Firefox. And if one of those is not working, switch to the other one. Once you log in, you're going to see your exams, okay? Now it's very possible that you're going to have exams from other subjects as well. So you have to make sure that you're clicking the exam for geometry. Believe it or not, I've had students start doing exams from other classes. For example, science or English. Or maybe they'll have an algebra test there. Make sure you're clicking the exam for geometry. This is what it should look like for your Topic 1 test. There's going to be 2 sections. When the day of the test comes, you have to complete both sections in the same day. That's what I wrote up here. Notice that your geometry exam has 2 sections that you must complete today. These instructions are not for right now. These are instructions. I'm going to show them again when you're taking the exam. You have to complete both sections on the same day. And you should start with section 1. Again, that's common sense, but you'd be surprised how many students decide to begin with section 2. Notice it says no calculator section. I wrote ignore this. You could use a calculator. They just put that on there to prepare you because the test at the end of the year has a section where you're not allowed to use a calculator. For these exams though, you could use a calculator on both sections. So just ignore this. Notice also right here it tells you how many questions are on the test, so you don't have to ask the teacher how many questions are on the test. The first section has 13 questions. The second question has 12 questions. That's a total of 25 questions. Once you click on the test, you're going to get this screen. Now, usually when students get on this screen, they start clicking here or they start clicking here and nothing happens. and then they call me to ask me what's wrong. Okay, that's why I put a big no here. Don't click on this stuff. Actually, if you click on it, nothing happens because it's just there. It's just telling you how to navigate through the test. That if you want to go to the previous question, you click this button. If you want to go to the next question, you click this one. When you want to submit the test, you click this button. But those are not actual buttons. It's just telling you that's what you do. To move on to your first question, you got to scroll further down. Notice that nothing else appears here. I did that on purpose because that's how it usually comes up on your screen. You got to scroll further down. Once you scroll further down, you'll see that down here there's a button to click to go to the next screen. That's where you would click to go to your first question. I'm trying everything possible to answer the questions that normally come up before you take the actual test, so that when you're taking it, you don't have to ask me these questions. Last part, okay? Once you click next, this screen comes up, okay? And when this screen comes up, a lot of students tell me, "Mister, my test is locked." But if you were to take the time to read this, it's just saying that test locking enabled. You are not allowed to leave the test to open another browser or application. Your test will be locked if you navigate outside of the test browser. What that is saying is a warning that if you leave the screen, if you leave your browser while you're taking the test, the program automatically locks the test, and it doesn't unlock it unless the teacher unlocks it. So it's just warning you before you start the test, hey, if you leave this browser or click anywhere outside the browser, even for 1 second, the test locks. And it does not unlock unless the teacher unlocks it. So keep that in mind. So that's just a warning. To begin the test, you got to click right here, Start Test. And then last thing before we start the review, I just want to remind you, I've already said it, but let me remind you, especially because we have some new students in many of my classes. Okay, the way I calculate my grades are like this. 50% of your grade consists of classwork and homework. So far, that's all we've had is classwork and homework. So that's all your grade shows. However, 50% of your grade is going to be exams and quizzes. So as soon as I add a quiz or an exam, it's going to have a huge impact on your grade. As soon as I add one exam or one quiz, it's going to have a major impact on your grade. So keep that in mind. Why do I do that? Because think about it this way. Let's make an analogy using sports. Okay, if we're talking about sports and you're on a team, doing the classwork and doing the homework, that's like going to practice and doing great. It's very important because if you don't do good in practice, you're usually not going to do good in a game. However, the game is the exams and the quizzes. That's where I need you to show that, hey, you really are learning. So that's why I count the exams and quizzes a lot, because it doesn't really help if you're great in practice, but when game day comes, you're horrible. On game day, that's when we can tell if you're really learning and can actually do the problems on your own. Okay? So that's why I count the exams and quizzes a lot. You need to take them seriously. The good news, though, is that if you pay attention to the review, you're going to be totally prepared for everything that's on the exam. There will be no surprises, and this is an awesome opportunity to get a really awesome grade on the exam and have an awesome grade on the report card. So don't think about this, all right? You can look at it as two ways. Some of you might look at it as oh no, now I'm scared. I'm going to do bad on the test and I'm going to have a bad grade. But there's no reason to look at it that way. Be confident. If you pay attention to the review, you'll be totally prepared, and it's an awesome opportunity to do really well on the exam. Okay? So you can look at it two ways. You can look at it like a winner or like a loser. Be a winner. All right? Be confident. And this will be a piece of cake, because I promise you, I'm preparing you for everything that's on the exam if you pay attention to the review. And of course, if you've been doing the homeworks and actually trying to learn. All right, with that said, let's start the review. Here's question 1. 2 lines that are coplanar. What does coplanar mean? I wrote it right here in parentheses in case you forgot. Coplanar means that they lie in the same plane. So 2 lines that are coplanar and are equidistant. Mister, what does equidistant mean? Okay, well, Equidistant consists of two words put together. The word distant, which is the same as distance, and the word equal. So you could take that to mean equally distant. They're equidistant at all points. They do not intersect. So what are those two lines called? Let me draw a picture to help you realize, all right? Two lines that are coplanar. So here's a plane. This part isn't that important, but whatever. They're on the same plane. And are equidistant at all points. Okay, so no matter what, they always stay the same distance away from each other. Okay, they keep going into infinity in both directions, and they always stay the same distance away from each other. What are those called? All right, those are called parallel lines. Parallel lines. Now, one thing I forgot to mention, I'll mention it right now, is that on my exam reviews, I try to disguise as many questions as possible, meaning that I always change the numbers. When there's numbers, I'll change the numbers so that you're not getting the answer that's on the test. I scramble the order of the answers as well, like the letters of the answers. And if the test is saying that, hey, you have to take this shape and move it to the left, I'll try to change it and put that you have to take the shape and move it to the right. So I try to disguise all the questions, but it's the same exact concept. However, there's some questions where I don't see the point of disguising it. This is one of those questions. This exact question is on the test, where they're asking you what are these two lines, and the answer is parallel lines. So this one is on the test. It's the same answer. It's probably not letter C. It's probably a different letter. There's no reason why you should get this question wrong. Okay, question 2. What is the rule for reflecting a figure over the x-axis, and what is the rule for reflecting a figure over the y-axis? I gave you an easy way to remember both of these rules. Let's go over that real quick. I said whenever you're reflecting over the x or y-axis, all you have to do is change the sign of the other letter. So for example, if I'm reflecting over the x-axis, I have to change the sign of the y-coordinate. So here's the rule. You get the x and the y coordinate. If I'm reflecting over the x-axis, I change y to the opposite sign. That's what that means. You change y to the opposite sign. So with that rule in mind, if I'm reflecting over the y-axis, that means I have to change the x to the opposite sign. Very simple to remember for reflecting over the x and the y-axis. Again, that's on the test. Okay, now, this question, there's a lot of words there. And some of you guys are easily intimidated by a lot of words, but this question is actually very simple. Let's read it, let's go over it, and then I'll show you how you can answer it in basically 1 or 2 seconds. It says triangle ABC is transformed to create triangle DEF and triangle XYZ as described below. So basically, triangle ABC, they're doing two different transformations to it. One transformation will give you triangle DEF, and the other transformation will give you triangle XYZ. Now let's look at what those transformations are. Okay, DEF, triangle DEF, represents a translation 5 units to the right and 3 units up of triangle ABC. So they're just moving it 5 units to the right and 3 units up. Now XYZ represents the dilation of triangle ABC by a scale factor of 6. Okay, this is an important word. Dilation means to make the triangle bigger or smaller. A dilation makes the triangle bigger or smaller. In this case, because you're multiplying by scale factor of 6, it makes it bigger. Is this part right here important? Not for this question, no. The only thing you need to know is that, hey, it's a dilation and that makes it bigger or smaller. Now, let's do a quick scan of these answers so that I can point out something. Okay, what are the differences in these 4 answers? Okay, well, first of all, in some of them, they're comparing ABC to XYZ, and in the other ones, they're comparing ABC to DEF. So that's the first thing I want you to realize. So in these two, they're talking about what happens when you change ABC to XYZ, and in the other two, they're talking about what happens when you change ABC to DEF. Okay, now here's the second part that I want you to pay attention to in the answers. The answers are saying, okay, does this transformation preserve the side lengths but not the angle measures? Does it preserve both the side lengths and the angle measures? Does it preserve the angle measures but not the side lengths? Does it preserve both the side lengths and the angle measures? Blah blah blah. Okay, so let me break that down for you here. In the first one, when you transform triangle ABC to triangle DEF, a translation, okay, a translation. Let me draw a little picture here. A translation. You're moving it 5 units to the right and 3 units up, but the triangle is gonna stay looking exactly the same. When you do a translation, the triangle stays looking exactly the same. Since it looks exactly the same, that means all the angle measures are gonna stay the same, and all the side lengths are gonna stay the same. That means they're gonna be preserved. When you preserve something, it stays the same. So when you transform triangle ABC to triangle DEF by doing a translation, the angle measures and the side lengths stay the same. They're preserved. You are preserving the angle measures and the side lengths. However, for XYZ, you are doing a dilation. A dilation makes it bigger or smaller. In this case, since you're multiplying everything by 6, it's going to make the triangle bigger, and that's not going to preserve the side lengths. Okay, that's not going to preserve the side lengths or the angle measures. So, from these 4 answers, what you're looking for is this one right here. Because when you change triangle ABC, when you transform triangle ABC to triangle DEF, since it's a translation, that's going to preserve both the side lengths and the angle measures of the triangle. I think with that explanation, the question is easy. However, let me point out what's likely to happen to a lot of you guys when you take an exam. All these questions, all these answers look very similar. And my answers are scrambled. Okay, so when it comes time for the test, and let's say you haven't looked at this review since we first went over it, and it's been a couple days, you're no longer going to remember what I said, and all the answers look extremely similar, and they're going to be scrambled in a different order, and all of a sudden you're going to get confused. What did he say? Did he say that it preserves the side lengths but not the angle measures? What did he say? So if you don't review this before the test, you will forget. With the explanation I just gave you, I'm telling you how you could answer it in just 1 or 2 seconds by realizing that the dilation one does not preserve anything. The translation one does preserve everything. And all you got to do is find the one that's saying that it preserves everything and it has the correct triangles listed. Let's move on. Number 4, a rectangle is shown on the coordinate plane below. Identify a line that the rectangle could be reflected over to result in a rectangle that has the same vertices as the original. First, let's make sure you understand the question. We got to identify a line that you could draw somewhere here that when you reflect the rectangle over it, it's going to line up with the same vertices. The vertices are this vertex, this vertex, this vertex, and this vertex. In plain English, where can I draw a line so that when I reflect the rectangle over it, it's going to land on top of the exact same rectangle that you see right now and look exactly the same? Before we even look at the answers, there's only two possible lines that could answer this question. One possibility is this line right here. I'll draw it as straight as I can, but it's not going to come out perfect. But one possibility is that line, okay? However, if you look where that lines up, it lines up in the middle of 2 and 3, which would be 2.5. There's nothing here that says 2.5, so it's not going to be that line. Let me try my other option. The other option would be this line right here. That's my other option, okay? And in this case, that's the line that we need to get the answer. But that brings us to our second issue. Our second issue is this. Is that line, first of all, it's at number 3. Is that line x equals 3 or y equals 3? Which of the two is it? Okay, so let me tell you how you could remember what's the equation for that line. This is going to come up throughout the entire year, and I'm going to give you a way that you could I'm going to give you two ways to help you remember which it is, all right? Let me first draw a picture over here. So let me draw a coordinate plane here. All right, so here are two ways that you could remember how to identify the equation for that line. First of all, obviously, this is the x-axis. The horizontal line is the x-axis. The vertical line is the y-axis. And here's the line that they're talking about. Okay, I'm going to explain it two different ways. The first way is this. I like to say, this is a little technique I came up with, that these lines that are either perfectly horizontal or perfectly vertical, the equation uses the opposite letter of the axis that is the same way as this line. So for example, this line is horizontal. The horizontal axis is x. So this line uses the other letter. So it's going to be y. Y equals 3. If I would have drawn a line vertical, it would have been x equals whatever number it lines up with. I'll say it again. So a horizontal line is the opposite of the horizontal axis. The horizontal axis is the x-axis. So the horizontal line is always going to be y equals whatever number it lines up with here. A vertical line is going to be the opposite letter of the vertical axis, which is the y-axis. So if I would have drawn a vertical line, it would have been x equals whatever number it lines up with. Okay, now why is it y equals 3? Here's another way you can think about it. Wherever I put a point on this line, it doesn't matter where, okay, wherever I put a point, if I were to write the coordinates for that point, the x coordinate will change, but the y coordinate is always 3, okay? Right here, the x coordinate may change, but the y coordinate always lines up with 3 no matter where I am. If I go back here, the x coordinate would be whatever's here. I don't know what number it is, but the y coordinate always stays 3. So this this equation of this line is y equals 3. And I'll give you one last way to remember it that I just remembered. So there's 3 different ways that I'm giving you. Okay, you may remember this from Algebra 1. This is called the slope-intercept form. The slope-intercept form, right here you write the slope. Right here you write the slope. Right here you write the y-intercept. And this does come up again throughout the year. When it does, I'll refresh your memory again. Anyways, when you have a horizontal line, the slope of that line is 0. And the y-intercept is where does that line cross the y-axis? In this case, it crosses it at positive 3. Now, 0 times anything is 0. So this cancels out. And that's why the equation of the line ends up being y equals 3. Okay, so in this particular question, the answer is D, y equals 3. Now listen, just because just because in this particular example I drew a horizontal line to reflect it, doesn't mean it's going to be necessarily like that on the exam. Maybe it'll be like this, or maybe it'll be a vertical line. Be prepared for both. Again, I try to disguise the question. Maybe you'll get one that's like this, or maybe you'll get one where the line is vertical. You need to be prepared for both. If it would have been a vertical line, the answer would have been x equals whatever number it lines up with here. Let's move on. Okay, number 5. Select each transformation that carries a square onto itself. So this question has to do with rotational symmetry, which we had a chapter on. Okay, so if we have a square, here's my square. If we have a square, it has to do with rotational symmetry as well as reflectional symmetry. But let's go over rotational symmetry first. A square has four different sides, 4 different angles. So every time, remember that if you rotate a shape 360 degrees, if you rotate it 360 degrees, it'll be back exactly where you started. And to find the rotational symmetry means how many times, what degrees can I rotate this shape and have it line up exactly on top of this shape that we have right now? So since it has 4 sides and it has 4 angles, if I divide 360 by 4, that tells me that every time I rotate this square 90 degrees around the center, this part is important. You have to rotate it around the center, not around anywhere else. But every time I rotate it 90 degrees around the center, it's going to look exactly the same. That means if it's every time I rotate it 90 degrees, that means if I rotate it 90 degrees, or 90 degrees times 2, or 90 degrees times 3, as well as times 4, times 5, times 6. But we're only concerned with the number of degrees less than 360. Because for any shape, if you rotate it 360, it'll be back where it started. Okay, so every time you rotate it, any of these degrees, it doesn't matter which direction, it'll be exactly on top of itself. Now, the key thing is you got to rotate it around its center, not around one of its vertices. So let's look at with that in mind, let's look at the questions. Okay, so the first I'm sorry, not the questions, the answers. The first answer says a rotation of 180 degrees clockwise about one of the square's vertices. Okay, so let me point out something. This answer is wrong because it's not saying to rotate it around the center. It's saying to rotate it around one of its vertices. So for example, what that would mean is this. This is wrong. If you rotate it 180, let's say it's there, and we rotate it around that vertex right there, 180 degrees, it would be over here now. Okay, so, and we're only trying to find the answers where when you do the transformation that it says, the square will be on top of the same exact square and look exactly the same. So that's why letter A is wrong, because this will not, a 180 degree clockwise rotation about one of the square's vertices will not put it on top of the same square. So A is wrong. Okay, B, a rotation of 90 degrees clockwise about the square's center. When you see that word about, that means like around the center. So yeah, that'll work. As long as you're rotating it one of these numbers around the center, it works. So B is correct. Letter C, a reflection over one of the square's sides. Let me draw that. A reflection over one of the square's sides. Okay, that's not going to work. If you reflect it over any side, let's say there's my square and I want to reflect it over this side right here, then you're going to get this square over here. That's not going to put the square on top of the same square. Or if you reflect it over this side, same thing. That's not going to put the square on top of the same square. I don't know why, but a lot of students get that wrong. It seems pretty obvious to me. If you reflect it over one of its sides, it's not going to land on top of the same square. So letter C is wrong. Okay, letter D, a rotation of 180 degrees clockwise about the square's center. Yes. If you rotate it 180 degrees about the center, that works also. And letter E, a reflection over one of the square's diagonals. This is another answer that I don't know why students tend to always ask me. Everybody should know what a diagonal line is. So here's my square. In a square, all the sides are the same length. That's what those lines mean, okay? Now, a diagonal line is this. So if you reflect the square over a diagonal line, yes, this side will be over here and this side will be over here. It'll match up. So yes, that is a correct answer. Now, this question is on the test pretty similar to the way I wrote it here. The answers are scrambled in a different order. So if you try to write down, hey, it's B, D, E, you're going to get it wrong because it's not going to be B, D, E. It's pretty, it's not that difficult. So please try to understand it because you're going to have other questions that are disguised that are similar to this. Question number 6. The line segment XY is shown below. Which transformation of segment XY will produce a line segment X prime, Y prime that is parallel to XY? So which one of these transformations will put this line in a way that is parallel to the one that you see right now, parallel? So let's look at the answers. Letter A, a reflection over the y-axis. Okay, here's my y-axis right here. If you reflect over that y-axis, you're going to get this. Something more or less like this. Those lines segments are obviously not parallel. In case you forgot, parallel lines are like that. Or in this case, parallel lines would be like this. Those are parallel lines. So if I reflect this line over the y-axis, I'm going to get that. And that is not parallel. So that answer is obviously wrong. Letter B, a rotation of 90 degrees about point X. Okay, so first of all, remember, if I have this line, let me make it easy, a horizontal line, and I rotate it 90 degrees, it would be like that. Let's apply that same concept to here. They're saying to rotate it 90 degrees about point X. It doesn't say what direction, but it doesn't really matter because this is wrong. But here's point X. If I rotate the line 90 degrees this way, it's going to be like that. It's going to give me, by the way, it gives me a perpendicular line. And if I rotate it 90 degrees in the other direction, it would give me this. Either way, those are obviously not parallel lines. So already these two answers are wrong. Letter C, a translation up 7 units. Okay, translation means we're just going to move the whole thing up 7 units. Somewhere up here. And yes, that is going to give me a parallel line. So that has to be the correct answer. Because when you're translating it, you're just moving it up 7 units, but it's going to look exactly the same as it does here. So C is the right answer, but let's also look at D to see why D is wrong. Letter D, a rotation of 180 degrees about point X. So again, we said let's pretend we're rotating it counterclockwise, but the other way would be the same thing in this case. If you rotate it 90 degrees counterclockwise, it would be this. If you rotate it 90 degrees again, it would be this. Okay? And the end result would be over here, something like that. And those lines are not parallel. They're on the same trajectory. Okay, so those lines are not parallel. So the correct answer would be letter C, a translation up 7 units. Number 7. Triangle ABC with vertices A, B, and C is graphed on the coordinate plane below. Which transformation of triangle ABC would yield triangle A prime, B prime, C prime so that BC, segment BC, is parallel to segment A prime, C prime? Let me explain the question again. And let me break it down a little bit for if anyone out there didn't understand the question. They're giving you this triangle. Which one of these transformations, remember that when I do a transformation, ABC is going to change to A prime, B prime, C prime. So which one of these transformations, when I do it, is going to give me a result that segment BC, which is this one right here, segment BC is going to be parallel to segment A prime, C prime. In the new triangle, segment A prime, C prime will be parallel to this segment right here. Which one of these transformations? Okay, so let's look at them one at a time. First answer choice, a reflection across the x-axis. Okay, if you reflect this triangle across the x-axis, it's going to be more or less here, here. Not more or less, it should be exactly here. Okay, so this will be B prime, C prime, and A prime. That's a reflection. Whoops, that didn't come out nice. A reflection over the x-axis. Now, is segment BC parallel to segment A prime, C prime? Well, let's look. Segment BC is right here in red, and segment A prime, C prime is right there. Those two sides are not parallel, so therefore, answer A is wrong. Let's look at answer B. A reflection across the y-axis. Okay, so if you reflect this across the y-axis, it'll look like this. This will be A prime, C prime, B prime. Always pay attention to the letters because there's a lot of questions on the test like that where you got to pay attention that the letters are being reflected correctly. So when I do a reflection across the y-axis, is segment BC, which is this one right here, segment BC, is that parallel to segment A prime, C prime? No, it is not. They are not parallel. So, and by the way, you should be able to picture all of this mentally. I'm just drawing it to help me explain it to you, but you should be able to do this in your mind. Okay, so B is wrong as well. Let's look at letter C. a 90-degree counterclockwise rotation about the origin. Okay, now we could go through the trouble of getting the exact coordinates and it wouldn't be that big of a deal, but I prefer if you realize that you could do it without getting the exact coordinates. Okay, so let's take this line right here, which is the line that we're interested in. If we rotate that line, that segment, 90 degrees counterclockwise, that's to the left, 90 degrees. Okay, the triangle, the new triangle would be somewhere like this. I'm just gonna draw it. Let me draw it over here, so I can just put it wherever. If you rotate that shape 90 degrees, all right? Did I draw that right? I did not draw that right. Let me try that again. Sorry, I drew that wrong. Okay, if you rotate it 90 degrees, you know what? Let me just write out the exact coordinates. Okay, the rule for a 90-degree counterclockwise rotation is that. You don't have to do this right now, okay? I'm just doing it to make it easier for my explanation to be more exact. All right, so point A is going to be, A prime is going to be at -4, -1. Okay, B is going to go to -1, -4. And C is going to go to, C prime is going to be at -1, -1. Again, you don't really have to do this. I just want to graph it perfectly to make my explanation make more sense. All right, so A prime is going to be at -4, -1. B prime is going to be at -1, -4. And C prime is right here. Okay, so now look, is segment BC parallel to segment A prime C prime? Yes, it is. Segment BC right now is parallel to A prime C prime. Okay, now this is what I meant to say at the beginning. Maybe I should have started with this explanation, but look, what I meant to say is this. If you just focus on this line right here, this side AC, if I rotate that 90 degrees, without worrying about putting it in the exact spot, if I rotate that 90 degrees to the left, you got to realize that it's going to end up here. Side AC would have ended up here, A prime, C prime, and that's going to be parallel to segment BC. Okay, so here, let me draw it over here. This is what I was trying to say. Okay, here's side AC, segment AC. If I rotate that 90 degrees to the left, it's going to end up like this, A prime, C prime, and you should be able to realize that when you do that, that side right here will be parallel to side BC, to segment BC. Okay, so again, you did not have to do all of this. If you just realize that the 90-degree counterclockwise rotation would put this side right here, that's all you need to do for the problem. And using the same concept, let's just look at the last answer, which is wrong. But again, on the exam, the answers are not in this order. So I just want to make sure you understand why D is wrong. D says a 180-degree rotation, a 180-degree clockwise rotation about the origin. Okay, so let's look at the same concept I just did, all right? Here's side AC. If I rotate it to the left, this says clockwise, which is to the right. If I rotate it to the right, 90 degrees would be that. Okay, to the right, 90 degrees would be that. And if I rotate it 90 degrees again for a total of 180, this side AC would end up like this. A prime, C prime would end up like this. And that is not parallel to this segment. Okay? So the best way to do it is to just visualize, this is the correct answer, just visualize, if you take this side AC, and rotate it 90 degrees counterclockwise, that side is going to end up like this. And it'll be parallel to segment BC. Okay, moving on. Okay, you're going to have this type of question on the exam where you have a table and you got to click yes or no on each one. If you get one of these wrong, the whole thing is wrong. Again, if you get any of these wrong, the entire question is wrong. So let's look at it. It says Abraham claims that perpendicular lines are lines that intersect such that at least one of the angles is a right angle. Okay, perpendicular lines, in case you forgot, perpendicular lines are something like this. They can look like that. In perpendicular lines, all four angles are 90-degree angles. All four of them are 90-degree angles. They could look like this. It's basically a cross, and they form 90-degree angles everywhere. Those are perpendicular lines. Okay, so it says here, determine whether each statement below justifies the claim. Select yes or no for each statement. So the first option, if one of the angles is a right angle, the angle vertical to it must also be a right angle. Now, you may have forgotten what that means because this is from middle school, I believe. Okay, vertical angles would be this. Like, when you have vertical angles, let me put a number. Let me say the number 1 and 2. Vertical angles would be like these two angles are vertical and these two angles are vertical. And when you have vertical angles, this angle always equals this one. So angle 1 would equal angle 2, and angle 3 would equal angle 4. Those are vertical angles. If I write it like this, same thing, okay? 1, 2, 3, 4. Okay, angle 1 equals angle 2, angle 3 equals angle 4. Angle 1 and 2 are vertical angles. These are vertical angles, and angle 3 and 4 are vertical angles. Okay? So if one of the angles is a right angle, so let's use this example right here. If one of the angles is a right angle, the angle vertical to it must also be a right angle. Yes, that is true. Yes. Second possibility, because linear pairs, by the way, let me erase all this. Because linear pairs are complementary, what does that word mean? Okay, and what does this word mean? We went over both of these. All right, let me refresh your memory. A linear pair is a pair of angles that creates a straight line. A linear pair is that. I could draw this line wherever, but it's basically two angles that when you put them together, they create a straight line. And how much does a straight line always measure? A straight line always measures 180 degrees, 180 degrees. Okay, now, I gave you a way to remember which angles are complementary and which angles are supplementary. Complementary angles are two angles that add up to 90 degrees, and supplementary angles are two angles that add up to 180 degrees. And I told you the way you could remember it is the letter C comes before the letter S in the alphabet, just like the number 90 comes before the number 180. So complementary angles add up to 90 degrees, supplementary angles add up to 180 degrees. Now with that in mind, let's look at this answer again. Because linear pairs are complementary, let's stop right there. Linear pairs are not complementary, they're supplementary. They always add up to 180 degrees. So right off the bat, that statement is wrong. Linear pairs are not complementary, they're supplementary. So right there, this answer is already wrong. No, that answer doesn't make sense. Last option. Intersecting lines allow for the creation of four angles with a common vertex. If that doesn't make sense, read the question again slowly. If you have two lines that intersect, or draw yourself an example if you're not understanding what the question is saying. If you have two lines that intersect, does that allow for the creation of four angles? Here are four angles that have a common vertex. All of those angles have a common vertex. Remember, when you have an angle, the vertex is where the two rays meet. Okay, so if you have intersecting lines, do they create four angles that have a common vertex? Yes, they do. So therefore, that answer is correct. Number 9. Number 9 is you just got to pick the correct picture. And it's pretty simple. It says, draw and label the final image of triangle ABC after the given sequence of transformations. They want you to reflect triangle ABC over the y-axis and then translate it by this vector. Okay, so first, one thing at a time. Let's first reflect it over the y-axis. Reflect triangle ABC over the y-axis. Okay, the first thing, I'm just going to draw it more or less where it's supposed to be, not exactly, okay? So the first thing I want you to realize is that if you reflect it, you're going to have the A prime will be there, the B prime will be here, and the C prime will be there. Make sure you realize the order of the letters. I'm pointing it out because it's on the exam. Make sure you realize that when you reflect it, the B is over here, the C is over here, the A is over here. Realize that. Okay, now in case you forgot what this means, that's a vector. When it has this on the sides, that's a vector. The first number, the positive 2, is telling you that you got to move the triangle 2 units to the right, 2 units to the right, because the first number is what you add to the x coordinate, and the x coordinate controls the movement right and left. If you add a positive number, it's going to move it to the right. If you add a negative number, it moves it to the left. And then the number over here affects the y coordinate. If you add a positive number, it moves it up. But if you add a negative number, which is the same as subtracting by 6, it's going to move it 6 units down. So basically, this vector is telling us to move the triangle 2 units to the right and 6 units down. So if you look at our options, there's only one possibility. It's obviously answer letter B. Alright? So that's an easy one. Number 10. Aaliyah claims that she can map rectangle ABCD to rectangle EFGH. Okay, so she claims that she could put, the word map means that she could put this rectangle ABCD exactly on top of rectangle EFGH. Select all the transformations or series of transformations that support her claim. So obviously this is telling you that there's more than one correct answer. You have to select all the correct answers. If you do not select all the correct answers, the entire thing is wrong. Let's look at each answer one at a time. Letter A, a translation of 6 units to the right. If you take this rectangle and move it 6 units to the right, it obviously doesn't line up because you also got to move it up. So letter A is wrong. Letter B, a reflection over the line x equals -1 followed by a translation of 2 units up. Let's look at this. A reflection over the line x equals -1. First thing is you got to know where is that line. So if you recall from earlier, I said that whenever they give you an equation like x equals a number or y equals a number, it's always the line is always going to be the opposite of the axis that has that letter. What I mean is this. This is the x-axis. So a line that says x equals -1 is going to be the opposite of that, which is going to be a vertical line. So x equals -1 is going to be a line like this. X equals -1 is this. So if I reflect it over that line, okay, let's look at this. X equals -1. Let's look at point D. Point D is at x equals -4. That's 3 units to the left of this line. So if I reflect it over this line, it's going to be 3 units to the right. 3 units to the right of -1 would be exactly here, where +2 is. Letter C would be exactly here. And letter A, again, this is at x equals -1. Letter A is at x equals -10. The x coordinate is -10. So that's 9 units to the left of -1. If I reflect it to the other side, it's got to be 9 units to the right of -1. 9 units to the right of -1 would put it at +8. Okay, so A prime would be here and B prime would be right here. So that would be right here, that would be the reflection over x equals -1. Now the next transformation that it's saying to do is to move it 2 units up. If you move the whole thing 2 units up, and by the way, in case you haven't noticed, this is moving in groups of 2. So if I move it 2 units up, yes, it does line up. So letter B is correct. That one works. Let's look at letter C. Let me erase everything I drew there though. Alright, so letter A is wrong, letter B is correct. Letter C says a translation of 2 units up followed by a 180-degree rotation about the point -1, 2. That sounds complicated. You're not going to have to do, you could just picture this, alright? So first of all, if I move this 2 units up, it'll be here. More or less. I didn't draw that that great, but it'll be there. Okay, now it says a translation, a 180-degree rotation about this point. This point is located right here. Look, if you rotate it 180 degrees, it's going to end up somewhere over here like that. That's wrong, all right? That's not going to work. So letter C is wrong. So A is wrong, B is correct, C is wrong. D, a translation of 12 units to the right and 2 units up. Let me pick a point. Let's pick point A. If I move, point A is at negative 10. If I move it 12 units to the right, point A would be right here. Point D would be here, B would be here, and C would be here. Let's put A prime, D prime, whatever. Same thing with D. D is at negative 4. If I move it 12 units to the right, it'll be at positive 8. So the rectangle will be there if I move it 12 units to the right, and then 2 units up. Yes, that will line up. So D is correct. Okay, so A is wrong, B is right, C is wrong, D is right. E, a reflection over the line x equals 0. Okay, remember that line, whenever it says x equals a number or y equals a number, it's always the opposite of the axis with that letter. So because it says x equals whatever, it's going to be the opposite of the x-axis. The x-axis is a horizontal line, so this is going to be a vertical line. And where does x equal 0? Right here. That's the line x equals 0. Another way that you could remember it is that wherever I put a point on this line, the x-coordinate is always 0. The y-coordinate changes, but the x-coordinate is always 0 wherever you put a point on this line. So this is the line x equals 0. So if you reflect over this line, okay, the rectangle would be over here. Let me make sure I draw it right. Something like this. Because this side is 4 units to the left, so I got to put it 4 units to the right. Okay, so it says a reflection over the line x equals 0 followed by a reflection over the line y equals 2. The line y equals 2 is right here like that. That would make no sense. That would put this like this. This answer makes no sense, okay? So E is wrong. E is wrong. Last one. A rotation of 180 degrees about the point -1, +4. Okay, first of all, -1, +4, that's right there. Okay, listen. A rotation of 180 degrees around that point. I don't want you to waste your time getting the coordinates, but this one is correct. This one is correct, and I'm putting it here because it's imitating what's on the test. This one does work. I want you to visualize, be able to visualize it. If you're rotating about that center, 90 degrees would put it, like if you're going to the left, 90 degrees would put it somewhere like that. 180 degrees would put it somewhere like that, okay? We're not somewhere. It would put it exactly where this answer is. So that one is correct. If I go through the trouble of showing you the exact how to get the exact coordinates, it's going to be a lot of work, and I really don't feel it's worth the trouble. I just want you to be able to understand it like mentally without actually having to write out the exact coordinates. But that is on the test, and that is one of the correct answers, right? Again, on the test, all the answers are scrambled, and they're not. I always try to change up the numbers, and if you're shaky on your understanding of this, when you see all the different stuff on the test, you're gonna get confused, and all it takes is one wrong answer to get the whole thing wrong. So this is worth reviewing and making sure you think about it and look at it before the exam. So those are the correct answers: B, D, and F. Okay, we're almost done. There's 13 questions on the first part that we need to go over. Number 11, based on the graph below, which sequence of transformations is needed to carry quadrilateral ABCD onto its image A prime, B prime, C prime, D prime? Alright, so just like the one we just looked at, we got to look at this carefully and go through several answers. However, I'll try to give you a quick way to answer it. We haven't, you know what, on this, I'm going to give you how you could visualize this without having to get the exact coordinates. Okay, so let's look at each one. Letter A says a 180 degree clockwise rotation about the origin. Alright, so here's the origin. The origin means 0, 0. This answer is wrong because if you rotate it 180 degrees, let's go this way, okay? Let's go to the left. We're starting here, and this is our ending point. If you rotate it 90 degrees, more or less, it's going to look like that. And if you rotate it 180 degrees, it's going to be in this quadrant, quadrant 1. When I rotate it basically every 90 degrees, it'll be in a different quadrant. The first 90 degrees will put it in this quadrant. 90 degrees again puts it here. 90 degrees again puts it over here. You know what? I'm sorry. Clockwise. I made a mistake here. And I'm too far in the video. I don't want to go back, so let me continue. The mistake was it says clockwise, and I did it counterclockwise. Okay, so let's go clockwise, which is to the right. If I rotate this 180 degrees clockwise, it would, first of all, 90 degrees this way would put it like this, more or less, somewhere like this. And then 90 degrees again would put it over here. Every 90 degrees, it's moving it into a different quadrant. So 180 degrees clockwise would put it over here, which is wrong. This is wrong. It's in the wrong quadrant. We need it in this quadrant. So letter A is wrong. Let's look at letter B. A 90 degree clockwise rotation about the origin, and then a reflection across the line y equals x. Okay, so first of all, 90 degrees clockwise, which is to the right, 90 degrees clockwise, about the origin, would put it looking like this, more or less, somewhere like this. I didn't draw it in the exact spot. And then a reflection across the line y equals x. Okay, now we haven't seen this in a while, but if in case you forgot, the line y equals x is a perfectly diagonal line. I went over this near the beginning of the year, like that. If I reflect it over that line, it's going to be somewhere over here. That's wrong. That's not going to be where we want it to be. So far, the first two answers are wrong. And I did not write out the coordinates. Just having a rough idea of where it's going to end up is all you need to have. Okay, letter C. A translation by this rule. This rule means that you're going to move the quadrilateral 7 units to the right. Okay, 7 units to the right. And then a 180 degree clockwise rotation about the origin. Okay, 180 degrees clockwise rotation. Let me think about this for 1 second. Okay, it has to be this answer, and I'm going to tell you why. In order to tell you why, let's first look at letter D. I want to first show you why D is wrong and why C is right. And this will allow me to explain it without having to write the exact coordinates, which will make it a lot easier to explain and to understand. Okay, let's first look at letter D, which is wrong. D says a reflection over the x-axis. If I reflect it over the x-axis, the quadrilateral is going to look like this. Hold on. Okay, that's a reflection over the x-axis. And then it says to a translation by this rule. This rule means you're going to move this shape 3 units to the right and 2 units up. Obviously, you can see it's pointing in the wrong direction. Okay, it doesn't have the same orientation as the one that we want. If you move it 3 units to the right and 2 units up, it's going to end up looking like something like that up here. If we think about this like a shoe, an upside down shoe, the shoe is pointing to the right here. We want it to point to the left. So it can't be D. Okay, so by process of elimination, it has to be C. So let's look at C, and I'm trying to avoid getting the actual coordinates to not do all that extra work. Okay, in letter C, it's telling us to do this first. When you do this first, it's moving it to the right 7 units. More or less, I'm going to put it more or less, something like that. Actually, wait. More or less right here. Now, you know what? It should be over here. My bad. I'm sorry. All right. It's going to be more or less over here. And then when you do a 180 degree rotation, it's going to put it. Remember I said that every 90 degrees, it puts it in another quadrant. Okay? 90 degrees, 180 degrees clockwise would be this way. Okay, so if I rotate it, again, let's pretend this is a shoe. Here's a shoe, right? If I rotate it 90 degrees, it'll be looking like this. If I rotate it, by the way, this is called a trapezoid, all right? But I'm calling it a shoe. Okay, if I rotate it 90 degrees again, the shoe is upside down. Okay, where it's supposed to be. All right, so I'm just showing you that on this one. If you have a rough idea of how it's going to look like after each of these transformations, without doing all the work of getting the exact coordinates, which could be a lot of work, all right, you could find the exact answer by process of elimination. 2 more to go. This is an easy one, so don't get it wrong. It says triangle ABC is reflected across line G. Here's my line G. To form triangle DEF. Which one of these is true? Okay, this has to do with, remember that, first of all, if you reflect it, this triangle is going to be congruent to this triangle, right? So when you do a reflection is is going to keep everything, the sides and the angles congruent. Okay, so that means that, for example, let's look at the first answer, which is I believe it's the correct one. Let me make sure. Yeah. No, actually it has a mistake. No, it is the correct one. Okay, so look, if I put the first two letters together, side AB corresponds to side DE. Side AB has to be congruent to side DE. Okay, now if I look at the second and the third letter, let me change the color here to make it easier to see. The second and the third letter, side BC corresponds to the second and the third letter here. EF, and that's what it's saying here, segment BC is congruent to segment EF. Okay, now the last one is a little bit of a trick question, a little bit. Okay, they say side CA. All right, CA is the third letter with the first letter. All right, CA is the third letter with the first letter. So it corresponds to the third letter with the first letter, which is FD. However, they wrote it. Oh, they did write it correctly. I'm sorry. I thought they tried to make it tricky. And I'm sorry, they did not make it tricky. It's straightforward. The third letter, then the first letter. So corresponds to the third letter, then the first letter in this one. So side CA corresponds to side FD. And you can also look at the picture. Okay, side CA is going to be congruent to side FD. So this side is still going to be congruent to this side. All right, so letter A is the correct answer. This question is pretty easy and straightforward. If you look at the other answers, and by the way, remember that on the test, just because it's letter A here doesn't mean it's letter A on the test. Just because I wrote ABC here doesn't mean that it's triangle ABC on the test. On the test, it's probably different letters. All right, so it's the same concept, but I switch it up to try to disguise it. So if you don't know what you're doing, you're going to get easily confused, all right? Let's look at some of the wrong answers real quick just to make sure you understand. B is wrong. In B, they're saying side AB corresponds to side EF. Really, you could just look at the picture. Side AB is this one. Side EF is that one. Those are not the same sides. Side AB goes with this one. So that's wrong. Okay? Same thing on letter C. Side AB with side FD. What? No. Side AB is this one. That is not going to be congruent to this side. No. So really, you can just look at the picture or the letters. You should use both. Okay? That's an easy one. Don't get it wrong. Okay, last question that we got to go over for today is this one. Okay, so oh, I messed up there. I didn't mean to put the answer, but whatever. Let's continue. Okay, it says in the diagram below, Martin claims that triangle ABC is congruent to triangle XBZ. The order of the letters is very important. The order of the letters is very important. On the exam, the letters are different from the ones I'm using. Okay, first of all, notice that they both have the same vertex, the same letter in the middle, B. All right, so it says determine which statements must be true. Must means they have to be true no matter what. They must be true for Martin's claim to be valid. So you got to check off which ones must be true, which ones may be false. If you get one wrong, the whole thing is wrong. So read carefully. And keep in mind, my question is imitating what you're going to see on the test. So let's go one at a time. The first one, triangle ABC can be rotated about point B to map it to triangle XBZ. So if you rotate triangle ABC around this point, if you rotate it, is it possible to map it? That means put it exactly on top of triangle XBZ. Okay? So notice that this side is a right angle, okay? So we could have a visual aid here. This side right here is a right angle. If I rotate it 90 degrees, it'll be like this. If I rotate it 90 degrees again, it's going to be like this. Sorry, I didn't draw it perfectly. But if I rotate it 90 degrees again, the 90-degree angle is here. It's the opposite of this. So no, that does not work. That does not work. So that one may be false. Okay, The next one, a series of rigid transformations of triangle ABC maps it to triangle XBZ. A series of rigid transformations. Okay, so you should see that it's possible to do a reflection. A reflection would put triangle ABC on top of XBZ. It'll map it exactly on top of that. Okay, a reflection is a rigid motion. A rigid motion means that when you do the transformation, it stays the exact same size and shape, right? Basically, every transformation is a rigid transformation except for dilations. A dilation is the only one that is not a rigid transformation because a dilation makes it bigger or smaller. Okay, number 3, the measure of angle A will be congruent to the measure of angle X. This is one of those where the first letter corresponds to the first letter. Yes, that's going to be true. And the last one, will side CB be congruent to side BZ? Side CB is this one. Okay, here's side CB. Will it be congruent to side BZ? Okay, listen, this is one where they're talking about the measure of the sides. Yes, the